Well, I can't really skip any of these because each of them has their own little element of confusion for you. So you look at these two terms here. You've got an x squared and an x term, but you have a coefficient that they have in common. You can actually take out a 2x. You're left with then an x plus 2. You set that equal to 0 and you have two solutions. One of them is a negative 2. The other one is a 0. You might want to say a 2 there, but if you set 2x equal to 0, you divide by 2, you get x equals 0. So 0, 0 is one of our roots. The other one is at negative 2, 0. And those 2 points right there, negative 2 and 0, are your two x-intercepts. And we spaced them out hopefully logically enough so that we can kind of recognize that there's only one space between, and we'll put the negative 1 there, the negative 3, the positive 1. Now our vertex is directly in between those, but it has a multiplier out in front, so we can't just do the regular stair step. The a value is not equal to 1 basically. So a couple things we can do. We can plug it in, we can complete the square. I haven't done any complete the square on this, but for one thing we don't have a lot of room. And for another thing, it just might be easier to plug something in once you know the center. So if we plug in a negative 1, we'll find our vertex. Negative 1 times 2 is negative 2. Negative 1 plus 2 is a positive 1. 1 times negative 2 is negative 2. Plot that point. There it is, negative 2. You could also kind of see that the stair-step approach works by a multiple of the a value out in front. So usually we'd go up 1 over 1, multiply that by 2, we go up 2 over 1. But I'll go ahead and plug something else in here. I'm going to plug in a 1 because it's a pain in the neck to plug in a negative. You plug in a 1 and 1 squared is 1. 1 times 2 is 2. Plus 4 times 1, which is 4. 2 plus 4 is equal to 6. Now, you might have said, well, why'd you plug in that equation and not this one? I plugged in this one last time. It doesn't matter. You plug in a 1 here, you get 1 times 2. You play 1 times 1 plus 2 is 3. So I have a 2 times 3. 2 times 3 is equal to the same 6 we got here, just a different way. And since we're talking symmetry here, if you plug in a negative 3, you'll get the same answer there. So 1, 2, 3, 4, 5, 6. Conveniently enough, it's right there at the precipice of the graph. And stair-step wise, up 1 to and over, one group of 2, and then up 3 groups of 2. 3 times 2 is 6. So multiples of 2 as we do our stair step, 1 over 3. That may have been confusing. I'll stop talking now.